So if we want to graph an inequality on a number line, before if we had a solution like x equals 7, when we were ready to put that on our number line, we would find that value 7 and we would say that this is our solution. Here's the point, and that dot is representing that one particular point. When we have an inequality, maybe we have one that says x is less than or equal to 7. Then it could be other numbers as well. We could have this 6. We could include 7 because it says x is less than or equal to. We could include 6. We could include 5. We could include 4. We would want to have lots of options, but not just those. Maybe 6.5 between these numbers or 6.25 between those. We want to make sure we cover every digit between 6 and 7. And between 6 and 5, and between 5 and 4. And we want to show that this is going to keep going all the way into our negatives. We could get down to -1, -2, and those are still going to be included because they're all smaller than 7. So on our number line, we're going to be working on our shading and the direction that we would shade. So we would indicate that all of these numbers starting from 7 and everything getting smaller than that would be the solution that we would show x is less than or equal to 7. So we have to think about making our number line, thinking that we have positive and negative values, that we create a number line with equal intervals. So notice that these numbers that I put are approximately equal space apart. We don't want to go from 7 to 8 to 200 in the same amount of space between numbers. That's what our intervals are. So we want to show that they're equal sized intervals and that we have some open arrows at the end. So in this purple here, the end of our number line like that. And then you notice when I was shading it that I have the end of this arrow colored in, so that becomes important later. So we have these two options, exclusive and inclusive, and we know the difference between these two symbols is that we had less than or greater than, and then here we have less than or equal to or greater than or equal to. So if we talk about this number 3 first, inclusive. In the example, we said x is less than or equal to 7. That means that 7 could be allowed. It could be part of the point because it's a or equals to. So 7 could be included in our options of solutions. And so we want to have that with a closed or shaded in circle, a closed circle. And that's saying that it's including our value 7. If we didn't have the or equals to part, if we had instead, let me make another one here, if we had instead the option x is less than 7, that means that it couldn't be equal to 7. It could be 6 or 5 or 4, but it could also be everything all the way up until 7, like 6.9999999 repeating. We want to show every value up until we actually get to 7. So to do that, we don't just want to start our graph at 6 because we're missing out all the other parts. So we put an open circle around, we put an open circle at the value that we're talking about and then continue our number line just like we did on the previous one where it had equals to. So if we're including the point, we want a closed circle. If we're excluding the point, meaning it can't actually be equal to that integer or equal to that value, then we put an open circle. And then for the symbols, we know that we're going to either be shading to the left or shading to the right. If we have numbers x is greater than 3, then we want the numbers 4, 5, 6, 7, 8, and so on. And those would be the numbers on the right. Oops, my pen, sorry. On the right side from your given value. For things that would be smaller, like x is less than 2, 1, 0, -1, -2, we're counting towards the left on a number line, so we'd want to indicate that towards the left. A little helpful hint is that if your variable is set up on the left, like x is less than 3 versus 3, or let's pick a different number. How about 13 is less than or equal to x. If it's set up on the left, like this one, then it's going to be a little bit easier to graph because you kind of have a little shortcut to help you know which way to go. So it's a less than symbol, so it's going to be an open circle. And then this symbol kind of mirrors the end of this arrowhead, and so that's the direction that we're going to be shading. It sort of points the same way. In this one, it's set up backwards. Our variables here on the right side. So we can completely flip the inequality. We can have here our x first and our 13 on the other side, but we have to make sure that we're indicating this symbol towards the right thing. You notice it's open towards the x. It's saying that the x value, our unknown value, has to be bigger than or equal to 13. So if we rewrite our inequality so that it's with our variable first, we need to make sure to flip the symbol as well. So then we can say, all right, well, here's our value 13. It's inclusive. We can include the point 13, and we want to go towards the right here and include all of the numbers that are bigger than or equal to 13.